Hi, Thoaif, and this is my presentation for E102. As you can see, it's a pretty nice device. It's a sunflower, basically. And what it does is it follows a light source, as in it turns towards the light source. Say if the light source was in this direction, it will turn towards that. And let me demonstrate that. But before that, it also displays the results on the screen, as in the red dot indicates the position of the device, and the yellow dot here indicates the maximum position of the light source given by the geometry of this. So, for example, also this grid kind of corresponds to the grid here, so it's kind of important to keep it. Alright. So, for example, if I turn this on and shine a light here, you can see that the red dot moves from the screen towards this direction. Okay. And well, actually, in this hemisphere, I mean the actuators can only move 180 degrees. This one has a rotation of 180 degrees. So if it can't find the light source at the end of its rotation, it will turn backwards and use a reverse logic to track the light source, as you can see. So once it stabilizes, the yellow dot will disappear, and you can see that on the screen. So actually this operates in two modes. This is actually the mode 1 right now, which I just showed you. But if I turn it to mode 1, you can see the whichever the light sensors are receiving the most light. Right now it's all of the sensors are receiving almost an equal amount. That's why it's showing an S here, an S. And that means stable basically. But if I shine towards, for example, D, it will display D and B and A and Z. If I turn it towards like two sensors, then it will show, for example, DC in this case. That's the second mode of this one. This device is adaptive to its environment, in the sense that it has a sensitivity measure built into it, which is actually displayed on the screen right now. The sensitivity is 31, so it is quite sensitive to the environment. Right now it will actually move towards whichever light source is there, but if I shine it with a bigger light, I mean stronger light source, it will turn towards that. And how it does that is by first calculating the average of all the light sources, and then finding out the deviation. And a control unit then decides which direction to move. Okay, so in this setup, you can see that the sensors, these are actually LDRs here, and they are connected to a potential divider circuit, which is this one, which is then connected to an analog to digital converter here. This is a serial analog to digital converter, which is then connected to the basis 3 FPGA. The basis 3 then decides how to move the actuators, and this is done through a technique called pulse width modulation, and then it moves the actuators. Okay, I also have some additional features. For example, I can display the output of any sensors. Right now, I think this is A. Oh, it's D. And I can display actually the output of any sensors. And also, I can display the position, I mean, the position of the device, which is in a rotation, it's 68 degrees, and it is tilted towards 116 degrees right now, and 90 degrees being this angle. And I also can display the estimated maximum position of the light source in this setup. For example, okay, for example, it thinks that the light source is at maximum of 193 degrees, which is about here actually. Okay, yeah. Okay, that covers it from my project. Once again, thank you for watching.